Thank you very much. Oh, this was too fast. Hello, everybody. Welcome. My name is Yasmin Markl. My colleague's name is Andreas Wirth. We are both working for ZAMG, the Austrian Institute for Meteorology and Geodynamics. And, well, yesterday I would try my best to replace my colleague, Liliane Hofer. Okay, I would like to start this briefing with a quick look at today's dust RGB from this morning, because I think one feature is very kind of representative for the last days, namely the yellow color. What we see is a very large area of yellow color, and this is fog or low stratus, so really low clouds that are lying over a huge area of Europe. And if we go back one day to yesterday, Monday, we see that it's a very similar picture. So also very expanded fog area and above other clouds, but especially at the ground, it's very overcast. Sunday also quite similar. Saturday a bit less, but at Saturday and Friday, we can maybe a little bit see where the fog came from, where it had its origin. So fog plays a big role those days, and we will come back to fog in just a couple of minutes. But now I would like to switch to another topic, and I would like to start with this model chart. It's the geopotential and temperature map at 300 hectopascal from ECMWF this morning, today. And I have chosen 300 hectopascal because I would like to have a look at the upper layer of our atmosphere. And I was thinking about which satellite image could represent the upper level best, or which satellite image or even RGB composite can reveal most features that are happening in a very high layer of the atmosphere. I want you maybe to think about it, and if you have a good idea, you can type it in the chat box or use the annotation tool to write it just on the picture. If you would like to allow to annotate. Okay, I think I have to open the chat box if I want to see something. Okay, so maybe you have an idea which satellite image is good for looking at very high elevations, 300 hectopascal. Anybody? I don't see anything so far. Still waiting a couple of seconds longer. Okay, here we have a quite good guess, EUMeTrain RGB or water vapor, yes. Exactly my opinion, so I would go for water vapor and of course also EUMeTrain because it contains both water vapor channels, so of course both, yes. I agree, thank you very much. And okay, stop annotating. Okay, so I have prepared the EUMeTrain, the water vapor image of the 6.2 channel for you. Here I would like to give you the chance to find low pressure systems. Use the annotation tool. Okay, I think it should be open for everybody. Maybe okay, should be fine now. Use the annotation tool and try to find low pressure systems on this water vapor image. I'm very curious to see what you're choosing. Okay. Probably the black line is a mistake. Okay, thank you. Yes, looks really good. Very interesting. Also, Thank you. That's enough. Great. I have overlaid this water vapor image with the geopotential at 300 hectopascal, where we can very nicely see the low pressure systems, and also that here we have this very well pronounced high pressure and this really kind of this very nice trough with very steep gradient. And what I want to show you on the next slide actually is that even if we have here these two lows, it must not necessarily be a low in a low pressure system in lower levels, as it might also be an upper level low, but we will come to this. And because we have talked about it, and I also have seen the suggestion of the ERMAS RGB, here is the ERMAS RGB, and here I would like you to point out dry air mass. And again, take a pencil, not a real one, please. And okay, annotation should work, I think. Yes. Okay, so find dry air masses on this picture. So we have trough over there and here. Yes. Okay. Thank you. That's fine. So basically, as a rule of thumb, maybe we can remember that where we have this red color. So, for example, over here, red color stands for dry air mass, and most often it's air mass that subsides from above. So it's subsiding air that is gives the red and is usually dry air mass. Thank you. And then we have this cold ozone-rich polar air mass, which resides in a very blue color, as we also have. We have several places actually where we have this blue color, and high-level thick clouds are also very nice and easy to identify. Those are the white colors, and also in connection with this nice cloud structures over here. But I think Andreas will actually go with you through these structures and some features in a couple of minutes. So I'm looking forward to this. Now I would like to go a step lower in the atmosphere to 500 hectopascal. This is again the geopotential and the temperature, where we quite nicely can see that some structures are different here. So these two upper level lows obviously are a little bit less pronounced. This one is more away for some kind of trough, while over most or big region over Europe we have high pressure and very weak gradients. I have chosen to look at 24 hours microphysics to look deeper into the atmosphere, and this is quite similar to the image that we have seen in the very beginning, the dust image, the dust RGB. Here also we can see this big area of fog or low stratus, everything that is kind of yellowish, or sometimes also going into pinkish, but I think you know what I mean. Actually, I think the parts here over Africa, this is not fog or clouds. This is the desert. Yeah. And I also have overlaid here the geopotential again, so we very nicely see what's going on. Very calm weather over Europe at the moment, and most things are going on here over Great Britain, Scandinavia, and also here, actually close to where we have this upper level low. And the red color is dense high ice clouds. And then we have also some cirrus clouds or very high clouds, which is a very dark color, either dark blue or going into black. if it's very dense. I have found something very special for this image. We have to have a closer look for this. I will zoom in to Austria, my home country, to show you the Ceilometer backscatter profiles. One for Salzburg here, which has been under fog now for a couple of days, and one for Radstadt that's not far away, but has experienced much more sunshine in the last days. And these profiles show us here for Salzburg that yeah, it's just covered with a very low cover of cloud, and I have a larger image of here the last hours this morning. So we see it has rised a little bit, but still it's very dense and low cloud. While here in Radstadt, there have also been mid-level or lower clouds at around 2,000 meters, but then sunshine with just a few higher clouds. And also today in the morning, we have these clouds that you also see on the satellite image, this red colored clouds that are traveling through and show that we are here between around 6 and 8, 9 kilometers, and then later today around 4 kilometers height. So that's very nice to see what's actually the height of the cloud. Okay, this brings us even farther, even closer to the ground. 1,000 hectopascal geopotential and temperature. So here the picture is very similar. Still the low pressure. What should I say? Not so much has left at the ground from this pressure system in the south. And I have, of course, chosen the fog RGB to look at the very low clouds in specific. And what's a very nice contrast here is the difference between snow here, for example, in the Alps, and the fog that is just lying next to it. Okay, now let's have a look at the webcam. This is Salzburg today. You see the castle in the middle, and oh, sorry.
We cannot actually see anything.
Okay. It's coming. One more. There we go. Okay. Sorry. Yeah, you see we have overcast weather here, and yeah, fog is sometimes closer to the ground and sometimes a little bit elevated. Sorry for this joke. Now I want to conclude with a very short outlook of the weather, and maybe we can find out together when we have the chance to get rid of this weather of this very persistent fog. This is from today. We have the geopotential and the equivalent potential temperature to the right side. Here we have a well-pronounced low pressure system north of, or yeah, approaching Scandinavia, and this will move on to the east and probably also affect mid-Europe regions, and hopefully will bring the chance to at least change a little bit, maybe on Thursday, to break up a little bit this cold layer on the ground and bring us the chance of few sunny spells. But I'm afraid that high pressure will be back and stabilize again the situation, so that probably over the weekend and then the beginning of next week, fog will again play a big role in our daily weather. This is now Sunday morning, so we will see if there will be a front next week that changes, brings big changes that can finally really dissolve the fog. But so far, I think Andreas is very happy today because Vienna finally is out of the fog and he has some sun. And actually, I'm done so far. And Andreas, you can continue if you like.
Thank you, Yasmin.
Thank you very much. For
Indeed,
yes.
we have much more sun. Unfortunately, the sun is going down already. So, but it was really nice and sunny compared to the last days. Yasmin, please let me share my screen now.
Of course.
Well, I have two presentations. This is the second one you're going to see, and first I would like to share my screen and perfect. So I hope you can see now the look out of the window of my director, or approximately. And you see the sky is not completely blue, but well, I'm still happy because the last days it was completely gray, and now we have much more sun, and it's really a delight. Well, I'm sharing my screen because I want to talk to you about, or with you, about the polar front. And yeah, here's the display of the image from 6 o'clock this morning. And I would like you now to start annotating. I will give you the rights soon. Well, the polar front is usually very easy. I'm tired of sound. Oh God, yeah. Okay, very funny. Yes, usually the polar front is a succession of cold front and warm front, and this is quite easily visible in the satellite image because yes, clouds are depicted nicely in white colors in the infrared, in the water vapor, and also in the air mass RGB, what you can see here. So it should be very simple, in theory, to draw a line where you can see, or where you guess is the polar front. And by the way, on this image you also see the subtropical front. And if you are, if you want to, now I give you the annotation rights, and I would like to give them to all. In the meantime, look at the image and try to find the polar front, and if you want, also the subtropical front. And think about what I said. It's a succession of cold fronts and warm fronts. Occlusion does not play a role in that. So yes, looks fine. Okay, very good. So you clearly define the polar front according to the cloud bands. Very nice. And that's what I would also do. But I tell you, sometimes it's tricky. So very nice. Polar front in the south, and sorry, in the north, and subtropical front in the south. And what you can see, if you don't have all these bars, is that the systems sometimes look very similar. We have a convergence in lower levels of cold and warm air masses, and we have a similar convergence of different types of air masses in the upper levels for the southern front, for the subtropical front. So if I click now on stop annotating, everything disappears. That's fine. Well, let's have a short look to my colleagues, what they did. I take the surface chart from this morning. Here it is. Well, and they did something similar than you did. You have the warm front. Well, and then we have the cold front that you annotated here, and then they say, okay, there's another cold front here. And then it continues, occlusion, warm front. Yeah. Well, here it is a little bit difficult, and I think also here it is a little bit difficult, and we will see why. So let's start in the east. Why is it difficult to put here the polar front? Well, the situation is not so clear. There are no clear cloud bands, and in this case, you really need the model fields that I will display now, and yeah, there are different methods to display the air mass boundary. You can either take the thermal front parameter, which was used very often. But in the case of higher resolution models, it's displaying a lot of different structures which are difficult sometimes to interpret. But still here in the eastern part, it's difficult. Well, this is not my favorite parameter. I prefer something like the thickness, because it clearly shows you where is the warm air mass and where's the cold air mass. So we have a cold front here, we have a warm front, then suddenly no clouds, and a frontal cloud band, or a cloud band that is in the south, but it seems that the air mass boundary is much more in the north. Then again, we have cold front, warm front, and here we have something like a trough. And most of the time, when you have a very pronounced trough or a cutoff low, then the typical frontal air mass boundary disappears in satellite image, and it's often hard to see where the polar front is without model fields. So I would like now to concentrate on that region here over the Atlantic. Most of you were drawing, and that's also what my colleagues did here, were drawing the cold front according to this cloud band here, and we will see that it is a cold front, but it's a special one, and a warm front. Why a warm front? Well, here's a low pressure system. You were seeing it already in Yasmin's charts. We have a surface low, and we have a low in higher levels, in 500, for example, and that's put also the surface. So you see it's from the bottom of the atmosphere until the higher levels. So it's a nice low pressure system. So if this moves to the north and we have warm air here, then this can be interpreted as a warm front, which is fine. And here is a cold front. But what we have also seen is, if we take the temperature field, that this is not the polar front, because the temperature gradient here in 850 hectopascal is somewhere in the north. We have the warm front here, that's fine, and then suddenly the front disappears. Maybe we can see some lower lines, but no high white clouds. This disappears, and then it continues here towards the east, which was really nicely seen. Well, so the situation is a bit more complicated, and I suggest that we take a cross-section now and put the cross-section, well, let's start from the cold air mass, maybe to the warmer air mass, and let's have a look what is displayed. We have the temperature, and we have, let's move it a little bit to the south, we have the equivalent potential temperature. And here you must be always careful with the equivalent potential temperature, because it combines humidity and temperature. So where is the cold air mass? Obviously it's here, the cold air mass. Well, and we see here the jump in the temperature. The 2 degree level is lower, and then it's higher up, and this is somewhere here. This is not corresponding to the clouds. What the clouds what concerns the clouds, this band here, this must be something here. And then we see also here a temperature gradient, warm air here and colder air here, but nothing on the ground. Well, there is some gradient, very steep gradient, but in the temperature field there is nothing in the ground. You just have a temperature gradient in higher levels. So as I told you already, we have a sign of a front, but this front is purely due to humidity. And you see the humidity here. These are the higher clouds. And here on the ground, we have also a humidity gradient that is reflected in the equivalent potential temperature, but not in the temperature itself, but only in humidity. Well, and what we see here is not the polar front, but how can we call it? It's an upper level cold front, if we want. Yes, it moves a little bit south. We would have to look in the loop. Then we could call it upper level cold front, but no cold front on the ground. I delete now the cross section, and well, what can we say if this is a stationary front. Can we find another conceptual model name for that? And for me, this is a typical sign. If we have a low that turns counterclockwise, and we have here the trough, which moves air in this direction, we have some field that where the air is moving in that direction, in the northeastern part, and in the southwestern part, it's moving in the opposite direction. And if we go to the wind barbs, we will clearly see that here in 300 hectopascal, the counterclockwise turning around the low, and here the trough movement. And such a system, which is under stress of two opposite turns, has the conceptual model name is deformation band, because it's stretched and deformed, and we call that deformation band. So you can either call that upper level cold front or deformation band, which is quite nicely visible. So all that just to say that it's the first case, follow the whitish cloud bands, but always be careful when you have some systems that look a little bit suspicious, as this one here. First, the cloud band is not consisting of very thick cloudiness. Second, you have some green air masses, that means already warmer air in the south and in the north of the cloud band, and not this typical reddish air mass that is typically behind the cold front. So this may not be the polar front, so the polar front is better to draw here than here. So, and now again, I want you to annotate, and I again allow you to annotate, all of you. Okay, and I would like you to show me where you find convection. Please annotate convection. Not the polar front anymore. Not just convection. Yes, yes, yes. Okay, I forgot to say. Forget the subtropical convection. Yes, you have a lot of convection here, but you have that all the time. Concentrate on the northern part. Yes, also in the cold air we find convection. Okay, you see, we find a lot of convection. Very nice. Though it's almost winter, and well, I pick out. Maybe I stop annotating now. Otherwise, we don't see the image anymore. What is the reason for convection in this area here? In the frontal area. Can you put it in the chart? What is the reason for that? Sorry, in the chat, not in the chart, in the chat. Can you write in the chat what do you think is the reason for convection here? The cold front, yes, exactly, very simple. The lifting of the warm air when the cold front arrives. What is the reason for convection here and here? Any idea? Low pressure, exactly. Yes, surface convergence, upper level divergence, lifting air, and that often leads to a phenomenon inside the core of upper level lows or older lows, and that the name for that is core convection. And then, and this is most difficult, maybe I change the color, right? Here over Greece, we also have some convection. What can be the reason for that? So, stop annotating. You know what I'm talking about, this region here? Well, there must be humidity. Okay, we're over the ocean. There must be instability. Let's have a look at Cape, for example. Well, fine. There is enough Cape. Showalter index. I didn't look at that, but Showalter index also shows here some instability. Well, okay, this is not so easy. And I think I found a reason for that. We have to look at the isotachs. Then we have here the isolines of wind speed above 30 meters per second. And now, well, the polar front is nicely visible with the temperature boundary, and but also the subtropical front is accompanied by a jet. And what is this region here? Look at the jet and tell me. Yes, I don't think that it is. Maybe it's occluded. Yes, it's the left exit region. So we have the jet cross circulation, and to confirm that, we have a look at the cyclonic vorticity advection, and the model really nicely depicts a maximum of the cyclonic vorticity advection. That means lifting air. So we have the cross circulation due to decelerating air, accelerating here, decelerating here. We have the cross circulation, and the rising branch of the cross circulation is exactly in this place here. And this leads to, this enhances the convection. This is the triggering of the convection due to the dynamics of the jet cross circulation. Okay, so this was a short intermezzo, and now I would like to go back to my last part. Oh, I'm already a bit late, but I thought it was quite an interesting situation today. I will stop sharing my screen, and I would like to go to the part I prepared for today. I hope you can see my PowerPoint, and there's a reason why I chose this topic, because there was a wildfire. I would like to, okay, I can move on here. There was a wildfire end of October, early November in Austria that was from the intensity as never before. I mean, it's still not comparable to wildfires in Portugal, Greece, Italy, but for Austria, it was really a wildfire that was exceptional, and I never experienced, I never saw and don't remember a wildfire that lasted that long and had such a huge extent. It was in the area of this orange circle, so it's already in the Alps, but not in the really high Alps. We have mountains of about 1,300 to maximum 2,000 meters, so not very high. To move on, here's the image. The situation is that it was not in the plain, it was on the mountaintop. You see here, this is already an image taken towards the end of the fire. It's not the trees that are burning, it's the soil, the wood on the ground that's burning. You see some smoke here, and since it's a video, I did not implement it. I just took one image. You see helicopters bringing water. There's enough water. There's a river here in the bottom of the valley, so there's enough water. The real problem is that it is very difficult to access it. So the fire extinguisher cars could not get there. There's just one possibility to extinguish this fire with planes, and Austria had help from countries, I think from Italy. They came with special airplanes to bring water on the slope of this mountain. So why do I tell you this? The thing is, I would like to have a look at satellite products that can show this fire, or that can detect this fire. And in the past, I was using some satellite products. And if you go to the EUMeTrain product guide and you enter fire, as I did here, you get, I think, 31 results showing different products from MSG over polar orbiting satellites, and also climatological products and so on. So there's a vast variety of products that can depict fire. In the past, I was experimenting with one product from the geostationary MSG satellite, the active fire monitoring, CIP, and this product is well suited for fires in the Mediterranean and also over Africa, but in the past it was never suited for fires that were happening in Austria. I looked at some cases, and also this case here was not detected by this product. Nevertheless, I think it's a good product. It relies on an algorithm that uses 3.9 micrometer channel, and it gives you two kinds of outputs, yellow for a probable fire and red for a probable fire and yellow for a possible fire. So different probabilities. Red is higher probability and yellow is lower probability. It works fine for the Mediterranean region, it works fine for Africa, but it never worked, unfortunately, for Austria. Still, the physics behind are well, and probably the resolution is too coarse. I hope with MTG we will get a better resolution and also a better fire product. If I continue here, I was made aware by one of my forecaster colleagues that there is another product that they use or they looked at to monitor the fire, and it's called FIRMS, Fire Information for Rescue Management Systems, and it uses polar orbiting satellites. And here you have the area where the fire happened, and two satellites were detecting the fire. It was Wirth and MODIS instruments. You see orange and red. Both satellites were detecting the fire. Unfortunately, and that's what my colleague told me, it's not enough precise to guide the rescuers or the fire brigades, because the fire was somewhere here in this area, and we have some indications here in the valley where we have the river, the Schwarza. Schwarz is black, so it's black water, this is the name of the river, and this was definitely not the region where it was burning. But for areas which are not densely populated, tundra, taiga, or some similar, this is a really good product. Since Austria is very densely populated, even in the Alps, smoke is seen by people and they alert the fire brigades. So satellite imagery is not really needed, but it was a nice test to see how it works, and it worked, I think, quite fine. It detected the fire, and I have, I think, another example here a few days later that also shows approximately the region. The region is here. This is a bit displaced, but okay, it's fine for the scale. Then I looked at another product, the Sentinel-2 images, which this is freely available. Both products are freely available in the browser. You have a very high resolution true color image from Sentinel-2, and this is the region near the mountains, where near the Rax mountain and the Schneeberg, where the fire started. This is a few days before it started. You see no clouds, no rain clouds, no smoke clouds, nothing, and you see the high details of the image. And if I continue, this was 24 October, 27, you can see the smoke plumes, you can detect the fire. This here are rain clouds or water clouds, but you can clearly see that these clouds here come from the fire. And a few days later, even better, no water clouds, but only clouds from the fire. You can nicely see the fire on the mountains, and this is a very good image that can help the fire brigade to locate the fire. The only problem with this product is that you have to zoom in very narrowly to get this region, and if you look at the calendar and see the overpasses, you see that you have 24, 27, and 29, and in between you don't have an overpass. So this is really a drawback. What is really needed is a geostationary satellite with a very high resolution that can depict small-scale fires. And this is the first time I have really seen fire in the satellite image over Austria. But I had to say again, it was a very intense situation, and well, it was seen and it was also detected in the satellite product. So I finish here with an outlook. Yes, what started the fire? Well, there are investigations ongoing. It could be man-made. We don't know. This is still under investigation. Well, the next weather briefing will be held by DWD, and I choose a nice winter image because probably we will see that quite soon and very often in the next days. So thank you very much